Okay, so yeah, then. Oh, you were able to see, Yana, like all the other participants?
I am. If you do the compact view, you will see them on the right. I just learned that from Shadi here.
Compact view members. Oh, okay. Okay.
Hi,
There are, there are like
my name's Mike.
11 people.
Hey,
Sorry.
hi, Mike.
Hi, I'm the volunteer, so if anything goes terribly wrong, I'll go looking for Rock, who's the other, the guy with the mohawk in the
Yeah.
other.
Yeah, he just joined us. So yeah.
Okay, I'll just be in the background if anything happens. One word of it. One word of advice: the muting on in the presence column can be a bit confusing. So the default should be to mute at the bottom of your screen rather than trying to mute and unmute, because you can end up muting yourself, like permanently muting yourself in presence, and then you can't unmute yourself at the bottom of the screen. So that's something that happened to a moderator yesterday.
Okay.
So I'll be
Fancy.
keeping. So yeah, so I'll be keeping an eye on that kind of stuff, and I'll send you personal messages if there are any outstanding issues.
Great. Yeah.
Thank you.
Thank
All
you.
right. Have a good session.
Yeah. Thank you. So I think like
Mike.
now we can go ahead. So I think I'm going to start sharing the screen now. Application window, share. So, okay. So I don't see the chat anymore. So yeah, I'm going to start now. Hello, everyone. Welcome to our tutorial session on information extraction from social media data, where we'll be talking about like a wide range of tasks, data sets, and some open source tools which we have developed. I'm Shubhanshu Mishra. I'm currently an NLP researcher here at Twitter. And I'm joined by Azwane Shadi Rezapor, who's a PhD candidate at UIUC, and also Yana Tiesner, who's an associate prof at UIUC, and also my advisor. A lot of the work which will be presented here is based on my PhD thesis, as well as the work by Yana and Shadi. And the URL link is provided below, so I will be posting it in the chat as well. Yeah. So, okay, so we can get started then. So before we talk about like the content, I just wanted to get some bookkeeping done. So we have a few open source tools which we are going to be using, and some of them like may take a bit of time to get started. So we are using this platform called Google Colab. So I'm going to show it to everyone. And all the instructions can be found at our webpage. So yeah, tutorials. Okay, so let me switch to sharing my browser then. Yeah. Okay. So all of you, the details of the tutorial can be found at, where did it go? At this URL. Wait a second.
So did you add yourself to the call? It seems like you have a recursive function.
Oh yeah.
I've done that when I logged in. That's somehow possible.
Yeah, I was trying to paste something in the chat. So can you all see my screen on the? Can you see my browser? Okay, yeah.
Yes.
So if you go, I just posted this link in the chat. So if you go to this page, there is a link to Google Colab Notebook. Google Colab is the platform which we will be using. If you have a Gmail account, then like it should be very easy. Otherwise, you need a Google account to access this notebook. If in case you don't have access to say Google, then what you can do is you can follow along and you can download some of the software locally. And some of these softwares are like actually like require a large amount of data download. So that's why we decided to go with Colab, because like you don't have to worry about downloading things on your local computer, which can be slow. So there is a link on the tutorial page which has details on setting it up on your local machine. If you have like a slow internet connection, I would not suggest doing it right now, because like it takes a lot of like time to download some of these files. But you can like follow along on the Google Colab page. Now I will show like what the Colab page is. So I just want to get like a heads up from everyone, like if you have access to this link and everyone is able to reach this page. Okay.
If you have any issue, you can raise your hand also.
Yeah, or post it in the chat.
Yeah.
Okay, so I will probably just give a quick introduction. So this is Google. So people who come from Python background and who have used something called a Jupyter notebook before, Google Colab is just like that. And it's basically an online notebook platform by Google, and you don't have to worry about like installing things locally on your machine and worrying about all those download processes. What we have done is we have set up a notebook which takes care of all the installation aspects as well as running everything. So we have prepared everything in the notebook today, and for now, just to start testing, what I would suggest everyone to do is just go here, click on runtime, and then click on restart and run all. If you are a regular Colab user, I would suggest making sure that you're not using a GPU. This is the default. So if you are not a regular Colab user, then don't need to worry about that. But if you are a regular Colab user, don't use a GPU, because like we don't need a GPU for this. For this notebook. And yeah, so what I would say is like just do restart and run all, and then we will continue with the tutorial. And it will take care of downloading and everything, so that when we come back to the tutorial, we are back to be able to see like how it looks like. Okay. And if you have any questions, feel free to post them in the chat channel, and we will respond to it. So back to the slides. How do I go back slides? Okay. Yeah. So as I mentioned, like these are all the setups. If you have an issue, you can also post it like outside. If you have any issues, you can post it in the GitHub channel for the project called Social Media IE, which is also listed on the tutorial webpage. Okay. So here's what the agenda is going to look like. We are going to first introduce what social media information extraction looks like. What are some of the challenges of it? Then we are going to talk about a wide variety of applications of information extraction from social media. As then we will talk about how we can collect and distribute social media data in the proper manner. And in the later section, we are going to do a hands-on practice for which we are going to use that notebook, which I just asked all of you to set up. And finally, like, yeah, we will conclude with some question answers. So, yeah. So in terms of, yeah, so what is information extraction? So the key idea of information extraction is that, like, often we have some unstructured data. So our scope for this tutorial is going to be mostly unstructured text data. So think of it like, just a bunch of text files. And the goal of information extraction systems is to convert that unstructured text data into some structured format. And when I say structured format are often like related to things which people know how to work with. So oftentimes, like, most people are like well versed in using like SQL queries, like so, and or like working with graphs. So effectively, like what these systems end up doing is like they convert these like raw text data into like some of these SQL tables or like say some graph format. And like the key challenge here is like if you have like large amount of text, then you want to do most of these things automatically, so that like you can scale it up to a larger amount of data sets. The next concept I want to introduce is the idea of digital social trace data. And here, the idea is that you have data sets which have, like, in terms of social media, they are not just like plain text files, but they are actually files which have some metadata associated with them. So for example, you have tweets which are made by users, and then these users follow each other, and then the trace data part refers to the fact that these data sets, like these individual texts or like individual posts, are actually ordered in time. So like all these things don't happen like on their own, but they are like actually ordered across time. So, and this concept is not limited to just social media data. Like in my thesis, like I also expanded it for non-social media data, like scholarly publications, where you also see like authors who write papers, and then like they basically, yeah, like each paper is ordered across time, and then papers cite each other. So where did it go? Okay. So an example of the digital social trace data is like something like this. Like, you have these two examples. Like one is the scholarly publishing data, which is based on time on the horizontal axis, and then each this PDF icon is basically a paper. Each paper is associated with a set of concepts. So these are like concepts which you extract using some of the information extraction techniques. And then you have authors. For each author, you also extract certain metadata, like based on their affiliation, or like say based on their gender, ethnicity. Some of these are like protected attributes. So like, but you may need it for identifying, say, some social phenomena. Same goes for social media data. Like you have tweets, and then like say, I'm taking example of tweets, but like you have like tweets, Reddit posts, Facebook posts, and then like these posts interact with each other. So you have like people who retweet things or quote tweet things, and then people like different tweets or associate multiple tweets together using a hashtag or a URL. And then all of these things are again ordered in time. So this is the key idea of digital social trace data. And we are going to exploit some of these structures later for efficiently extracting information from these data sets. Okay, so why is my, yeah. So when we talk about information extraction tasks, in the basic sense, like let's say we only are restricted to text documents, we don't have all these additional structure, then we can break down information extraction tasks across 3 levels. One is, so given a text, you can think of a text as a list of words, or oftentimes what people call it a list of tokens, because like not everything is considered a word. So like, you have punctuation marks or like some longer units of words, which are like, say, phrases. So oftentimes, like, you have token level system. So you may want to extract a span of tokens, or you may want to identify what each individual token in a sentence refers to. So these tasks can be like examples of named entity recognition, part of speech tagging in a document, or word sense disambiguation, or entity linking. The second task, which is like the much more common task, which a lot of people are aware of, is like document level task. Is these are like, you are given a text, and then you only care about getting a single label for that text, or like, say, a list of labels for that text, but you don't have to do anything with the structure of the text as such. And these tasks often, like for social media data set, are related to, like, say, identifying sentiment, or whether this, like, say, text is like referring to a hate speech, is it sarcastic, what are the topics associated with this text, what kind of, like, is this text related to some sort of a spam, or like, what are the relations expressed in this text. Again, relation extraction is slightly more general. It's a mixture of the token and document level, but I've still like usually like try to get like a general label for a given document from not at the token level. And the third task is basically like a corpus level task. So now, like, you can make inference at the level of, or make predictions at the level of each document. But now your information changes if instead of just giving you one document, I gave you 100 documents. So now you can make a collective inference or a collective prediction about, like, okay, what is there in the whole corpus, not just in each document, but in the whole corpus, what is there. And those tasks are like, if people have worked on topic modeling, so that's like one of the very popular ways of identifying a corpus level signals. Then we have like things like taxonomy construction. So given a large number of documents, you can identify, okay, which type of words are a subset or like hypernyms or hyponyms of different words or entities. And then key phrase extraction, like, what are some of the important key phrases in this whole corpus, which summarize the corpus. So now we are going to talk about like some examples of like the information extraction task, which I mentioned just before. So like I've just taken like a random tweet, and like these are some of the possible labels, document labels, which you can identify for this tweet. So what you're seeing here is like these are various systems which have been developed for classifying tweets. Some of them do it at the abusive level. So for example, this system by Fonta, they identify whether a tweet is abusive, hateful, normal, spam. Another one by Wasim identifies whether it's like racist, sexist, or none of these. Then we have like sentiment is a very standard task. And then we have like certain labels around uncertainty, whether like, this is sarcastic or not, or like what is the veridicality of this tweet. Again, like this is related to uncertainty. The second, as I mentioned to you, like the token level tasks, these are like sequence tagging tasks. So most popular ones are like part of speech tagging, named entity recognition, chunking, and CCG parsing. So here again, like, you want to identify like, which set of words refer to like an entity, or like which individual word refer to what kind of part of speech tag or noun phrase and so on. So what are some of the application of information extraction? I'm going to first talk about like very basic ones, and then we are going to talk about many of them in detail. So one of them, as I mentioned earlier, like the idea of information extraction is to go from unstructured text to structured text. So one of the simplest application is like, to convert a set of documents into a table where you can like, now later search that, okay, find me all the documents which have the entity Roger Federer mentioned in it. And or maybe like, if it have the entity Hilton, but it was mentioned as a person. So probably referring to Paris Hilton instead of say Hilton Hotels. And like you may want to also link those entities to say something in a knowledge base. So like if they are like say two Rogers, then you want to know like whether you're talking about Roger Federer, the tennis player, or some other Roger. So now we are going to talk about some specific examples of information extraction. As I mentioned to you earlier, like the key goal often is like, just to index social media corpora. So once you have these labels, now you can basically populate a database table with these values, and you can just have like a table which is like a document ID and then the label, and so that like later you can run queries on this set of data. The second is like constructing networks from this text corpora. And as I mentioned earlier, like, some people work with graphs. So you can also construct text-based networks from your corpus. Third is like, visualizing some temporal trends. So like temporal aspect is also present in almost all social media data sets. And this is possible because like almost all social media posts have a timestamp associated with it. And also like aggregating user level signals. So like there have been like a lot of tasks where instead of inferring at a individual post level, people try to make inference based on the user level. So like, what this user's interests are, or like, whether this user is spammy or not. And also like these applications are related to analyzing social debates. So these are like, some of them are like corpus level analyses, or like you can even look at like if you have a subset of say social media data sets, say for COVID, then you can even identify some corpus level statistics around like, okay, what are the needs or what are the main crisis events happening in these data sets. And like Shadi and Yana are going to talk about some of these COVID related specific cases later. So moving forward with the entity based example which I took earlier. So oftentimes like one very simple thing which people can do is like, just take identified entities and cluster them together, so that like, if you have Washington mentioned in a tweet, then you can have different types of Washington, one referring to Washington the place, one referring to Washington the person. And sometimes it's not possible to assign an actual label to like what the type is, but you can still cluster that, okay, these Washingtons look like the same entity, and these other Washington look like another cluster of entities. The second example is to do network construction from text classification. And here, like I've given like two examples. Like one is from my research with Yana, and another one is also like from Yana and Shadi and other people's research, where you can construct basically networks from the text data based on how users are talking to each other, or how entities are connected to each other. So in the left, we basically tag each tweet with a label, whether the tweet is enthusiastic or supportive of a given social cause. And then we connect users which are mentioned in the same type of cause, and we identify the most influential users for who are enthusiastic for a cause, or who are most supportive for a cause. On the right is an example from an email corpus where you basically construct signed networks based on like, how people are communicating based on the sentiment of their communication. And then you use PageRank to identify like a different type of influential users in this corpus. The next example is basically like, and this is like, so people who use Twitter, like, you might know like there's something called trending topics. So, and this is like a very old studied problem. Like this is a paper from 2013, like where like people study like how you can identify events or trend in a given Twitter stream. And again, this requires a temporal aspect of your data set. Finally, in the temporal aspect is the idea like that you can visualize some of these trends. So like I've basically built a visualization tool which you can use to visualize like how trends are how different posts are distributed across time and by various people. So here is an example of a Facebook group, visualized Facebook group of a course. And like on the bottom, you have like different posts in the comments in the group, and on the top you have different posts, and each comment is linked to a post. So you can use it to identify which posts are influential, how the comments on each post are distributed across time. So next, I'll pass it on to Shadi and Jana to talk about some other applications of social media corpus.
Thank you so much, Shup.
Yeah.
So yeah, thank you. So as Shup mentioned, beside all the models and methods that we have and we discussed up to now, we can also leverage lexicon-based approaches on models to describe or extract information from our data. For instance, imagine that you have a set of tweets or like a set of text and related to a specific topic, for example, election or COVID-19 or any other things that you are interested to know how people are feeling about it, or are they happy, or like what their opinions are, and so on. So you basically want to know what the sentiments of people's discussion is. So you either can, as Shup mentioned, you can use the classification models, which are trained on other data sets that may or may not be related to your data and your domain, or you can also use some of the lexicons that are available for you and create your own classification and extract if the text is positive or negative in your data. So there are a lot of lexicons that are already available online, and people are using that on daily basis. So one thing that we should focus on, and it's important when we are using lexicon, it's important to consider where this lexicon is coming from, what data was used for creating it, and if the domain and the words that are present in the lexicon is appropriate for your data and represent your data actually. So, and if not, then there's a need to a domain adaptation and some pre-processing to, and then you employ some methods such as error analysis or annotation to validate your results and see if the approach that you employed was actually useful for your data. So here in these next slides, I'll talk about some of the works that we have done by leveraging different types of lexicons to study social media data. Next slide, please. Thank you. So here in the first study, I will talk about one of the works that we did for the presidential election. So we wanted to know what the sentiment and what the sentiment of people was, and how was the likability of the US presidential candidates in the 2016 primary election. And we used Twitter for that. So for the purpose of our study, we first extracted tweets related to each of the candidates for a certain amount of time that we were interested in. And so after that, we selected a subsample of the data to explore what type of information is included in our tweet and how we can analyze our data. So after looking into the data, we observed that the hashtags that we had for in the election data actually for all the candidates were actually like having some weights, like some of them were positive, some of them were neutral, and some of them were negative. And so we thought that we can leverage these information as well as the words that we have in the tweets to analyze the sentiment of our data. So following this observation, we wanted to test whether incorporating these hashtags that were salient in our data into a lexicon-based sentiment analysis could increase the prediction accuracy. So for this purpose, we extracted hashtags for each candidate and annotated them. Like we annotated more than thousands of the hashtags that occurred more than 100 times in our data. And then we added them on top of the MPQA subjectivity lexicon, which is one of the most frequent used lexicon for studying sentiment. It includes more than 8,000 words tagged as positive, negative, and also it includes part of speech of the words, which is very useful for the purpose of sentiment analysis. So we used the combination of our hashtags and the MPQA lexicon, we studied our data. We also used a bunch of baseline models and classification models to see if the approach that we had was giving a better result compared to this baseline. And we found that actually that using domain and data specific information can actually increase the efficiency of the models and the prediction of sentiment in our data. And domain adaptation of the lexicon helped us to better analyze the data that we were studying. Next slide, please. Thank you. So apart from that, in the second study that I'm presenting here, we also used another type of lexicon approach to explore if using moral foundations can help us to study social effects, like, for example, stance. So the main intuition of this work was based on the idea that people's background, values, and cultures impact their perception and are reflected, and those values and everything are reflected in people's use of language and word choices. And so, as Chomsky said, a language is not just a word, it's a culture, a tradition, a unification of a community, a whole history that creates what a community is. It's all embodied in a language. So we can say that, like, when people are expressing their opinions regarding these social issues, their values and biases and cultures are involved, actually. And so when we are studying social effects, using some instances of values can help us to better investigate people's language. Therefore, we wanted to explore if the consideration of personal and moral values can help us in predicting or studying social effects like stance analysis. And you may ask, why stance? So stance is one of the ways in which the speaker position themselves in a relation to a topic, such as, for example, abortion. So when you're talking about this topic, so when you're taking position toward this topic, you're expressing your culture, your attitude, your personal values, and so on. And so you're either in favor of this topic or against. And this is just one of the examples. So we assume that bringing some features that represent values can benefit the stance prediction, like in theory and practice. Next slide, please. Thank you. So based on this intuition, we use moral values to investigate this problem in more details. And you may ask, what is moral values, or what does morality mean? So based on the Oxford Dictionary, morality is defined as principles that are cutting the distinction between good and bad, or right and wrong behavior. So, and for our study, we leveraged the moral foundation theory and the moral foundation dictionary that represent the theory of the morality in the textual format. And this dictionary associates words to 5 basic moral categories, for example, harm versus care, fairness versus cheating, and so on. So this dictionary that we talked about, the Moral Foundation Dictionary, one issue with this dictionary and lexicon is that it is very small in size and scope. It just has like around 300 words that are representing 5 basic moral category, and also a miscellaneous one. So we first had to create and extend this version of the lexicon, which is syntactically also disambiguated, because this lexicon does not include part of speech, and part of speech is actually very important for studying morality in the text that we were using. So for that purpose, we first added different forms of each word to our lexicon in terms of their part of speech. And then we used WordNet to add the hypernym, synonym, and antonym of each word to our lexicon. And as you may know, WordNet is a lexical database of semantic relations between words and link words with their semantic relations, including like words into semantic relations, including their synonyms, their hypernyms, and their antonyms. So we added all these direct information like the synonym, hypernym, and antonym of each word to our lexicon. And then we analyzed each word with respect to their part of the speech, with respect to their moral category, and with respect to their meaning. And then, like, we removed the ones that were not suitable for our study. For example, a word like safe as a noun, we found that does not have any moral weight, but it's a word like the synonym of it, like for example, sanctuary as a noun could have a moral meaning, like moral weight and good meaning for our lexicon. Or noun as an adjective was also suitable. So we pruned our lexicon, and we carefully disambiguated everything. This lexicon is also available, and if anyone is interested in using this extended version. So to study the effect of morality in analyzing the social effects, we used two different data sets. One of them, and both of them are Twitter data set. One of them is the Stance data set, which is a benchmark data set, as I mentioned, consisting of tweets related to 6 social issues as abortion, atheism, climate change, feminism, Donald Trump, Hillary Clinton, and they are all tagged as in favor, against, or neutral toward these social issues. We also used another data set as related to Freddie Gray's protest, which were like represented in the Twitter. So after that, and after we expanded the lexicon, we used both the expanded lexicon and the original lexicon separately to extract the moral features from our data set. And then we used a classic machine learning model as well as a deep learning model to explore if leveraging this information could help in enhancing the prediction of social effects. And we found that, like, in more than 90% of the feature-based model and more than 85% of the deep learning models, we could see the extent, like we could see that we could increase the prediction accuracy. And we also found that lexicon expansion was worthwhile as it improved the prediction accuracy also in majority of our experiments. So we found that using morality as a feature was actually helpful for 2 standard NLP tasks and some implications of personal and moral values, and like specifically morality in NLP task could provide useful input for analyzing social effects. And we can use this approach for other tasks like sentiment analysis, emotion analysis, and so on, since using people's culture and background can provide some important information like personal level information and community level information regarding people's sociocultural settings. Next slide, please. Mm-hmm. Next, thank you. Following this work, we used the concept of stance and utilized different types of social data, social media data sets to examine cross-cutting exposure on social media. So a cross-cutting exposure describes disagreement in viewpoints encountered by individuals. And as you may know, like interacting only with people who think like us can result in filter bubbles and echo chambers. So cross-cutting exposure, which brings like different viewpoints to the table, is very beneficial for enhancing political participation and democracy and so on. And one issue with works related to stance is that the majority of them are actually just focusing on enhancing the performance of the prediction models, and they do not look closer into what users' opinions are regarding different aspects and what they are discussing in 2 sides of the communication actually. So in this research that I'm presenting here, we analyzed polarized viewpoints by looking into the common aspects that were discussed in tweets written in favor or against various controversial issues. And then we compare the context of those words using people's network and like different types of linguistic analysis. In the work that I'm showing here, we use the topic, this is related to feminism data set, and we use topic modeling to extract different types of topics related, like in the tweets that were written in favor or against feminism. And so as you can see in the graph here, there are words that just are related to favor and just are related to against. However, what is important for us to look into are the aspects that are shared between these two viewpoints, to see how people are talking about these words, first of all, and also how these words mean for each side. If like people have the same concern or opinion regarding those like shared aspects, and how these shared aspects are actually resulting polarization. So, and we believe that like understanding these commonalities and differences between the aspects can help us in having a more efficient communication and bringing the two sides together. This is still a work in progress, and we hope we can share the results with you like in the next month, hopefully. Next slide, please. Thank you. So finally, the last work that I'll talk about here is how we used Twitter to detect needs in tweets related to COVID-19. As you know, like social media platform like Twitter, Facebook, Reddit, and so on contain a vast amount of information about people's opinion and needs. But also like these platforms can also include a lot of noisy content like advertisement or like adversaries and so on, that that makes it challenging for people who are in charge, like practitioners, to efficiently and effectively actually identify these shared information on these platforms. There were a lot of works in crisis informatics that leverage Twitter for crisis, like in crisis, like for example, earthquake or tornado and so on, to extract what people's needs were, and if they were they were actually the resources that people needed were available to them after they expressed the needs. So in this study that I'm presenting here, we proposed two different methods that are novel for our study. These methods are distinct but also somehow related. In the first one, we identify a list of resources that were needed, and then we rank them by their priority, and then we identify sentences that specifically mention who needs what resources actually in the tweets. For this purpose, we first extracted and collected more than 500,000 tweets using keywords related to COVID-19, and then we use phrase detection method to extract salient phrases in our data set, and then use word embedding to find the top nouns that are closest to the word embedding of need and supplies. In addition to that, we also developed a rule-based model to identify who needs what, these sentences that include who needs what, where who is the entity, like a person or a city or something, and what is the resource or item that was needed. So we leverage the grammatical structure of sentences by using a dependency parser to identify sentences that contain this triple. We developed two simple rules to identify these type of sentences. The first rule had to consider need as a verb, like as you can see here in this picture. So X needs Y, for example. So and then the second rule was that need is a noun, and we extracted the sentences like, for example, Illinois needs Illinois is in need of PPE. So need was like both verb and noun in our sentences. So for these tasks, we compared our results for task 1. We compared our results and resources that we could extract against 2 available lists of resources that WHO and HHS actually released, and we could achieve more than 64 precision for the resources that we extracted. And for task 2, we actually annotated some of the results, like more than 1,000 of the tweets, and we evaluated the result of our study, and we could see that like we could achieve more than 68% F1 score using the method that we used. Next slide, please. So on the same vein, the availability of social media data and the importance of the topics such as COVID-19 resulted in a huge amount of work related to this issue in the past year. So we see a lot of work, and this resource that we have online are very rich, and people can study different types of topics, from opinion mining to misinformation related to COVID. And I think recently there was also a work regarding like misinformation regarding vaccination. They also used, like researchers used this data for studying, for extracting actually what symptoms people expressed online, and it could be very useful for people, medical labs and practitioners to actually see what type of symptoms people are expressing. They also studied how diverse the language is now that the COVID hit people. So they compared the language diversity around the world and compared it with the data set that we had from previous years. And also researchers used this data set to study how COVID-19 impacted the mental health of people, and using Reddit. So a lot of studies were performed to study very diverse topics. So the availability of these data sets resulted in a variety of researchers and works in the past year in different conferences and journals. And of course, these results that we see can help us to analyze and understand how crisis, for example, like COVID, impacts people, and what strategies can be used for mitigating the negative consequences of this problem, or how we can help and support the communities, like in terms of mental or physical health. However, when we are using this rich data set and resources that are available to us online, there are some factors that are needed to be considered, which we'll talk about in the next slides. Thank you.
Before I move to the next section, I just wanted to take any questions if people have on the wide variety of work which we have presented.
I will repost the link to the slides. Okay. Oh, the shop actually note, I'm not sure about that. Did you also share the slides? We only shared the link to the notebook.
No, I only shared the link to the notebook, not the slides yet.
So people who are interested,
yeah,
people who are interested, just email us. You can see our email addresses as our usernames, and we can share them.
Yeah, and I will post the slides after the session on the tutorial webpage. So it will be listed on the webpage under section slides.
Thank you, Shub.
Yeah.
Are there any other questions or comments that folks might have?
You can also raise your hand if you don't want to type them in the chat, and we can bring you up.
Well, then let's continue.
Okay. So, from current slide. Okay. Okay, so next session, I will be discussing some importance of collecting and distributing social media data, and like there are some important factors to be considered. So before we start, like one of the important things is that a lot of the social media data is already publicly available through their APIs, and this data set is produced by individuals, but at the same time, these individuals have only agreed to the platform on which they are posting their content. So oftentimes when we take their data set, we have to be very responsible in working with those data sets. And there are certain, like most of the platforms also in their terms and of services also provide like certain restrictions on like, how the data can be shared, how the data needs to be taken care of, and all those things. And yeah, if you're using some of these social media data sets in your research, then like, be wary about some of these aspects. So one of the main thing which we'll want to highlight is that like it's important when you like use any data set, like it's important to like, document and consider like, how it was collected, like what were the time ranges, like what kind of sampling was done on this data set. And if the data set is actually allowed in the allowed form to be used in your research. And the third is like because of the nature of social media, when it's changing very rapidly over time, like you need to also consider whether this data set is representative for your specific research question, and whether it will lead to some generalizable findings. So in terms of publicly available social media data sets, what we have available is there's a large amount of social media annotated data which the existing research community has made available. And if you're purely working on, say, building machine learning models or like trying to improve some information extraction systems, then these can be very good source for benchmarking how your algorithm works. Most of these data sets, which I'm going to talk about, are related to text classification. As I mentioned like earlier, like sentiment, hate speech. There are few around like other information extraction tasks like named entities, part of speech tagging. But like, as we move away from classification tasks, like the size of some of these data set reduces. The third important aspect is like, even if like, let's say if you have like multiple data sets for sentiment, and as I showed you in the previous slide, like there were 4 different kind of sentiment type values. Each data set has very different annotation guidelines. So in reality, you can't just merge all the data set together, assuming that the labels in each data set mean the same thing. Maybe in one data set, like positive means something else, whereas negative means something else. Or maybe like oftentimes like it's the neutral label, which is like the most shifted across the data sets. So what we have done is we have prepared a resource called MetaCorpus, which I'm going to show everyone, which is a web page with all the large number of social media data sets already listed. Sorry. So let me share my screen back to. So yeah, if you go to the MetaCorpus page, it actually also has a GitHub page. So I will just go on that. It's a large collection of data sets from various social media platforms on different classification tasks. So you have like data sets on hate and abusive speech, on crisis identification, identifying biomedical entities related to election, movie sentiment, topics, emotions. and geolocation, factuality, translation, news. And then you also have like, and like basically this data source is like continuously growing. So like I keep adding data sets here. And you also have like, apart from that, like you have data sets for categorized across non-classification categories as well. Like for stance detection, for part of speech tagging, there are multiple data sets. Named entity linking, there is data set. There's a data set for tree bank. So like the research with Shadi showed, like where you have like where they used like the dependency parser. Oftentimes, like these dependency parsers are trained on news data. So people have worked on trying to improve them even further on social media data sets, which have like slightly different structure. So you can use some of these data sets for benchmarking across different type of language dialects, like on African American dialect compared to normal English, like the non-African American dialect of English, and how they differ. And another thing which is quite popular in social media is like code switching. So like if you are saying a sentence and in the middle you'll start using like, say, some other words in your own language which don't often exist in that language. So that is called code switching, and that is also very common in social media. So there are data sets which are for benchmarking code switching systems as well. Also, like there are data sets around machine translation, paraphrase identification, rumor detection, question answering, as well as some multimodal data sets where instead of just making prediction on text, you make prediction on, say, text plus images of the tweet or like of the social media post. And then there are like some large like corpus which are like related. So for example, this is like a COVID Twitter data set, which has like, I think around, it's a growing data set of a few million tweets related to COVID. So this is a non-annotated data set. It's just like a big corpus. Same goes for some political tweets. There's, if you want to study like, say, how politicians tweet, there's like this very nice resource on like US politician and like the archive of all their tweets. Similar, there are very few data sets available for Facebook, but there are like some data sets for Facebook as well. And similar for YouTube, where people have studied YouTube comments. Reddit is actually like very open. So you can actually download the whole Reddit corpora and you can work with it. So like there have been quite a few data sets based on Reddit. I have few listed here. And then Gab is a very new social media. So there are like few data sets around that. And yeah, off late, like people have started also creating some WhatsApp based data sets. So again, like the reason like why it fits here is like it's like a private social network, but often people study public groups in WhatsApp and they use it to study like, how rumors or how hate speech spreads. Apart from that, there are a lot of challenges which happen every year. So some of these challenges are already listed here. Like these are like online competitions around identifying, say, improving named entity detection in tweets or sentiment analysis in tweets. So many of these things exist. So yeah, this resource is also listed on the tutorial page, if I'm not mistaken. Or I will add it later. But it's, if you go to the social media IE page, you should be able to. If you go here, you should be able to find the Metacorpus link, and I will add it here as well. So it's called like social media IE/Metacorpus on GitHub. So going back to the slide. Any question about this data set? Okay. Okay.
We have a question.
Yeah. Oh, okay.
Oh, actually, it's a comment. Twitch there's a comment about Twitch that could be a good place for that, maybe.
For Twitch, oh yeah, I think yeah, like Twitch chats are also like I've seen. I haven't added them to this dataset, but if you know of some good Twitch dataset, like yeah, feel free to send a pull request here on this repository. It's an open repository, so anyone, if you have suggestions for adding some of your datasets, like yeah, you can suggest them here, and like we can integrate it in the corpus. Yeah. Yeah, I will post the link in the chat.
I think I did post that, but I don't
Oh,
know.
yeah. Shadi already did that.
Yeah, let me paste it again. If you have difficulties reaching to this link, let us know.
Yeah, and I will also post the link to the GitHub page for the same thing.
Perfect.
Yeah. Okay. Okay, going back to the slide. Okay, so now I'm going to talk a bit about like the specific area which I have mostly worked on for information extraction. And the two tasks which I've mostly worked on are tagging and classification. So there are a few data sets around tagging of, so when I say tagging, I mean like token level labels for tweets and in general social media, and also for classification. So the first, and I want to give you like a kind of a map of like what is available. So if you look at like, these are all the various tagging data sets. Mostly they are classified under four types: named entity recognition, part of speech tagging, supersense tagging, and chunking. If you see a name like Ritter, which is like quite common across all the data sets, because this data set is like kind of one of the original data sets for doing information extraction on tweets. So people have re-annotated this data set with additional labels. And that's why like this data set is quite common. So if you are training, say, some model, you need to be aware that like, you know, this data set is, the input is going to be quite same. The output is going to be like, of course, different across all the data sets. Another thing which I want to highlight is that like if you see, oftentimes compared to the general English, so people who work in machine learning, for general machine learning work, there are a huge amount of data sets available based on like Newswire or like news formats, which are like usually longer in text. So they have like larger number of tokens or larger number of documents. So compared to them, with like, you know, for tweets, we usually have like much smaller data sets, like usually in the scale of around like 1,000. So this is probably like the largest training data set of around like 10,000 tweets. This is the Finnin data set. But apart from that, like all the other data sets for tagging are like quite small.
Are you, sorry, I think your slides are not shared.
Oh, sorry.
Confirmed.
Oh, shit. Okay. Yeah. So yeah, this is the data set I was talking about. Like these are all the various tagging data sets. This is the Ritter data set, which I was mentioning. And yeah, like as you can see, like most of the data set are quite small. So this is the number of sequences is basically the number of posts. And you see like mostly they are like a few hundreds to a few thousands, like not even 10,000. So this is like one of the largest data set for tagging tasks, which I've used later for one of my research work. Coming to classification, it's slightly better. You usually have like much larger classification data sets. So these are all like classification data sets. Mostly sentiment is the most popular task for social media data sets. So there's a lot of sentiment data sets for social media. Hate speech or abusive content identification has become like another popular task these days. So there are like a growing number of data sets for hate speech or abusive content identification. I've listed a few. If you go to the like Metacorpus page, there are like much more listed. There's actually a whole directory just dedicated to abusive content identification, which some other researchers maintain, which I've also listed in the Metacorpora. And next is like uncertainty. So it's basically kind of a mixed bag of like two different types of data sets. Like one is related to actually identifying uncertainty indicators. And the second is related to sarcasm, which I also like clubbed under uncertainty, because like sarcasm is like uncertain information present in the tweet. Now coming to how, if you have never collected Twitter data and never annotated data, how you're going to do that. So they're like almost all social media platforms have an API. I have mostly worked with Twitter data during my PhD and also like some Facebook data. So both of them have their own APIs for which you need to request access. And once you have access, they give you some like credentials to use their API. So if you are if you want to work with tweet data, then this is a tool which I've used quite a lot during my PhD called Twark. And I think let me maybe just share my whole screen so that I don't have to. Screen. So Twark is one of the very popular and very old datasets. So all it requires is basically like you provide the credentials, and then you can use it to effectively find, like, say, hydrate, like filter tweets or get the tweet JSON from the API. So do you still see my slides?
Yes, we do.
Okay.
Shoot, there is a question that how about Tweepy? I know it's one of the other APIs that came.
Yeah, so Tweepy is also another like a wrapper on the API. So all these tools use the same API. I've used Tweepy as well. And they all do like similar things. The reason I like Twark quite a lot is for some of the features. It's a command line tool. And it has a lot of features where you can just like enter a search query, and it will keep like, storing data sets based on that search query for you like over time. Or if you have a list of tweet IDs, you can directly hydrate it. So you can either use Tweepy or you can use Twark. For people who don't have programming background, I would suggest using Twark, because this is like just like a command line tool. There's also recently another tool from the same team called Twark GUI. I think it's called Hydrator. Yeah, so Hydrator is another one which is basically a GUI-based version of Twark. So if you have, like, say, if you don't want to work on terminal, basically, like, you can just create a new data set by saying that, okay, I want to create these different data sets, and this is how I want to export them. And it is going to like generate all your data sets for you. So I haven't used this one. It's slightly new, but I have used the other data set, the other Twark tool. And this team actually publishes quite a lot of tweet sets, the creator of Twark, and they have created a large number of data sets for various topics. So like, US election, and often like, Women's March, Olympics. I hope there's COVID also here. No, or there's like one for climate change. And you can see like they have collected quite a huge number of tweets for all of them. Yeah, there is one for coronavirus I saw. So there's around like 354 million tweet IDs for coronavirus. So yeah, you can basically play if you want to do some corpus level analysis. These are all like data sets you can use. Remember, these are not annotated data sets. So again, like you can use them or maybe annotate them yourself and then share those annotations. So back to this part about work. So now coming to how you share tweet some of these social media data sets. Oftentimes, like most social media data sets will not allow you, platforms will not allow you to share the whole data. So like when you query a tweet using its tweet ID, you will get a big JSON which has all the fields in it. But you are not supposed to share that as a public resource. So the best thing which researchers follow is just share the IDs and your labels. So you can have any label which you have generated. You can basically like associate a label to that ID and then just create a data set of that and share it like publicly. And there are like restrictions on like, how many tweet IDs or tweet ID plus labels you can share. So you please check the terms of service of that. But same goes for all the social media platforms. The good thing of this approach is that, so one thing which is very common is like people tend to delete their accounts or like people tend to delete their posts on social media platforms. So the reason for sharing only the IDs and not the text is that if they delete their account or delete the post, then if someone regenerates the data, the deleted data should automatically be gone, because like, that's not part of, like you will not get it back from the API. But that also includes a new challenge on the dataset, because any benchmark which you create on social media data is going to be always like depleting, because like usually like a huge number of posts are often deleted from most of the social media corpora. Yeah, so you need to be wary of that part as well. Any questions around this? Sure. Okay. Yeah. Jana, you want to talk anything about like data sharing and collection? Jana, based on the work that you have done on various platforms.
I don't know if Jana's connection. I cannot see her.
Yeah. Okay.
Maybe we can ask her later.
Yeah. Okay. So let's get back. Okay. So now we will go. We'll talk about various methods for doing information extraction from tweets, and this is where we are going to use notebooks. So the first tool, which is like a very GUI-based tool, which was built like in Jana's lab, like I was happy to be like part of this. Like when you're starting this tool. So it's called Context. So if you are coming from a non-programming background, this is a tool which you can use to like extract various like information from, say, any type of text data. And like we have used it quite a lot for social media text data. But it comes with an additional feature that you can also extract text-based networks. That means like co-occurring entities or entities which are related to each other, say, based on some of their dependency relationships. You can extract all of that using this tool using a GUI format. So like for people who would like to not use, say, a programming-based tool, this is a pretty good tool to use. And the next one is like one of the most popular approaches for doing information extraction is just identifying entities in posts or in text. And for that, we basically built like two different tools. First, I'll tell you like a simpler tool, which which is an older tool, and it requires on like very non pre-deep learning features, just like a list of lexicons, or what we call gazetteers. These are like basically you have like huge lists of say names of people, names of organization, location, or music bands, and you couple them up with say some general regular expression that okay, like these type of entities follow this format, and then you train it with some unsupervised in some semi-supervised fashion with some large amount of unlabeled data to get a pretty good quality model. So this model is like publicly available at Twitter NER, and it does not require any like say deep learning like library dependency. So like yeah, it's pretty simple to use. And this model like performs like it's one of the best models publicly available on this specific benchmark for tweet named entity recognition. It's a very hard benchmark, but yeah, like we got like close to the second best performing system. The first one is like a closed system, which is not available. And yeah, like it performs pretty well across, especially across like person, organization, location categories. And especially, so if you are coming from, say, if you have some background on NLP, then and if you have used Stanford NLP before, so Stanford NLP works very well for news data set, but for like say social media data set, it does not perform that well. So like using a social media tailored tool is much better and suggested. The second thing, the second type of tool we have is a multitask, multi-dataset learning tool. So now, if you remember from earlier, like I showed you, like there are like different types of tagging and classification datasets which we have available. And I also highlighted that the amount of dataset in each task is very small, like so in the order of hundreds or thousands. So if you train any model, like oftentimes it will not generalize very well, and that's why like you often see these like lower accuracy scores on many of the social media benchmarks. So the way to address that issue is like we try to use a multitask learning setup, where we, instead of using a single task training, like instead of training one model for each task and each data set within each task, because the reason is like different data sets follow different annotation guideline, we actually just use a single model which learns all the tasks, and then it has some shared knowledge, and this shared knowledge allows it to generalize, to improve. Improvement on one task causes it to improve its performance on the other task. And we considered like we compared again 3 types of models. So one is like single task, single data set, which is like the traditional setup. The second is like single task multi data set, which is like you are only doing NER, but within NER you use all possible NER data sets. And then the last one is multitask multi-data set. So instead of doing just NER, you do NER plus part of speech tagging plus chunking plus supersense tagging, and you share the information across various layers. So how do these multitask models perform? So if you see our best performance compared to like the state of the art for each of these things, we improve. For most of the data sets, we improve by quite a lot, like 5 to 2%. And the improvement is much higher in named entity recognition, where like, for some of the benchmarks, like we get like much higher numbers across all the data sets. Supersense tagging and chunking also, like we get like pretty good output. Now, the major benefit of some of these approach, and this is what I'm going to show you in the notebook, is not just the fact that, okay, some of these models are better, but like sometimes they are like not as good as well. But the fact that they are not extremely bad on like any of the data sets, what this causes is that if you have a single model which can perform all these tasks to a reasonable accuracy, like sometimes better, but like most of the time pretty reasonable accuracy, then you kind of like, save yourself from like trying to run like different pipelines and different toolings to just get like your labeled output. So effectively, if you just use a single model, you will get all these outputs, and then later you can use those outputs for performing like your analysis, which is again going back to the fact that most of the time all you care about is putting things into a database, and then when things are in the database, like you have your structured data in a database, you can simply run your analysis on that data. So this single tool like can allow you to get like very high quality data into your databases. I'll not go about like the details of training. One very important thing instead, which I learned is like, if you go back to this figure is like, we have these shared layers or what I call like shared outputs. So what happens is like the model first builds a general representation of each word or each sentence. So if it's a classification task, then the model will learn a general representation of the sentence. Or if it's a token level tagging task, then the model will learn a general representation for each word. And then that representation is used to make prediction on all the tasks. And this this approach allows us to know that the way like most of these models work is that they effectively they get a representation for the input, and then they also have internally they learn a representation for the label. And what they do is they find a similarity score for the input and the label and use that similarity score to make the final prediction. So what we can also do is, the way these models are set up is we can actually use this information to identify that what those labeled representations look like. And this is what we explored here in this aspect. So remember, we have different data sets all about part of speech tagging. And the model does not know that these are all different data sets about part of speech tagging. It only knows that like these are like different tasks I have to perform. But the model automatically learns after learning, because it has learned a single representation for the input, and it's trying to make sure that the representation aligns well with the outputs. It actually automatically learns to cluster outputs which are differently named in different part of speech tagging data sets into similar clusters. So you have like here a cluster of all the different verbs. You have here a cluster of all the different nouns. Another like for pronouns, proper nouns, a big cluster here for punctuation. And this is quite consistent across not just part speech tagging, but also say for named entity recognition, you have again all the person like, so in named entity recognition, the way we define spans is like we identify the beginning of a span and then the inside of a span. And you see like all the beginning of persons are clustered together. Some data sets like use the label PER, some use PERSON, and all of them have been clustered together. Same goes for location. Some data sets use location, some use geolocation, some use facility, and so on. And again, like all of them are quite clustered together. This is like a pretty broad cluster, but like, mostly around like TV shows, movies, which are like similar types of things. And not just that, like we also see that the direction of going from B to I is quite common across all the data sets. So that means going from the beginning of an entity to the inside of an entity, that direction, like that representation direction is quite common. And the way I've prepared these figures is basically each representation of a label is a vector, and then we can basically project those vectors or like somehow transform those vectors into a two-dimensional vector, ensuring that things which are closed in the high dimensional space are still closed in the low dimensional space. So that's how like these similarity measures make sense. Similar things we also see in chunking. Again, like very common direction for B to I, and then like, there's only single data set. So the only thing we can look at is the directions. And also for supersyntagnian, there we see like a very distinct cluster of all the nouns and all the verbs. And within each noun and verb, we again see like, this direction of going from B to I. So all of this, this tool, like which I have built and I'm going to talk about, is like actually available as a fully standalone tool. You can even use it to investigate how your model performs on a given data set, or say on a given tweet, and it will give you what are the predictions on all these tasks. So these are the tasks which we consider, like different type of part of speech tags, different type of NER tags, chunking tag, and CCG tag. And you can use this GUI tool to like get everything aligned for each token, because it's a token level task. Same goes for classification. So as I already told you, like these are the various classification data sets. And in classification, again, like we get like by using multitask learning, we get like pretty good accuracy for across all the data sets. Or like if we don't get very good accuracy, we are like still amongst like a reasonably good accuracy. And again, the same thing comes in terms of label representations. We see, which we call like label embeddings, is like, all the positives are clustered together, all the negatives are clustered together. And in fact, abusive and hateful are also clustered with the negative. So this is like kind of similar. You see like even sexism is similar to negative. And then all the neutrals or non-neutral style labels like none, normal, not sarcasm, they're also clustered together. So this is like a pretty promising that like, the model has learned without us providing any specific information around these things, that these labels mean similar thing. Yeah, and same way, like, this is the web GUI which I have, like, so you can use it to also explore the output for all the models. And just remember, like, it's a single model which is giving you all these outputs. So you don't have to run like all these, like how many, like 8 different models. You only run the model once and you get all these labels, and you can use it later for your analysis. The next challenge, so before I move forward, like any questions on this?
I think there was one question in the chat about, let me see, it's loading. So can you point to studies that combine data from different social media platforms like Twitter and Reddit?
There are a few. I mean, like in my study, like some of these dates are actually from Reddit. So I've used it's, so that's why like it's a very generic, but there are quite a few. I can probably add them to the tutorial link. Yeah, but in general, oftentimes people study different things on different platforms or social media. Like on Twitter, mostly people just study like, say, general like trending conversation, short conversations. On Reddit, people usually are interested in studying threads. So they're like more thread style databases, data sets, more around conversation data sets for Reddit. Whereas for Twitter, most of the data sets around like individual post level analysis. Yeah.
Let us know if this answers your question. If not, please raise your hand and we can talk more about it.
Okay, so I will move to the next section. So here, like, so till now we have addressed like, how we can identify like various type of information. We can identify them quickly. But oftentimes, like, we are not very blessed to have like so much data. And if you are trying to create a new task or say a new text classifier with new set of labels, you often don't have a lot of data. So what you can do there is like probably start with a small label data set, or maybe like 100 or 200 examples, and then use the model to, along with your unlabeled data, to actually generate a larger labeled data set. Or effectively, the way I look at it is, if you have a big corpus, like say maybe like 10,000 documents or 10,000 posts, then what you can do is simply, your goal is simply to get all those documents labeled, but you can't label them all manually. So what you can do is you can label some of them, then use a model trained on some of that label data to predict to all the other labels, and then go forward and effectively label all the whole corpus by just correcting some of the errors which the model have made. And this is where we get into the idea of active learning. And active learning is basically this field of machine learning where you use the model to suggest you what to label next. And so the model is always running, and then it keeps suggesting, maybe you should provide me this label so that I can improve myself. And it's a very interactive human in the loop approach, which I think oftentimes for social analysis, which we anyways follow. And if you can integrate it well with the machine learning model, it's quite beneficial. Another reason why it's very important for social media data sets is because social media data sets are streaming data. They are not a static corpus of let's say if you're only interested in studying all the plays of Shakespeare. So Shakespeare is dead. There's not going to be any more plays of Shakespeare, or I hope not, right? I mean, so you have this fixed corpus, so it's not going to change. But in social media, if you only want to study COVID, the information on COVID is always changing. So you can always use an existing model to identify, okay, I still want to identify maybe needs and supplies in all the tweets, but maybe in new tweets, there are some new needs which have come up and my model is not performing well. So instead of going and trying to just annotate everything from scratch, you can use the model to suggest you what data to label next. And the way active learning works is you start with a model and some unlabeled data, and then you select some samples from that unlabeled data to be annotated, and you use some selection criteria. And the selection criteria is very important, as I'm going to talk about later. And then the model suggests that, okay, why don't you label these examples? Then you label them those examples, and they are used as labeled training data for the model later. And you keep repeating this step till you reach a reasonable accuracy. So the system which we built is based on a slight variant of active learning. So not just using a model, but we also create some lexicons on the side, because lexicon can act as some rules which you can impose on your data. So oftentimes, if you know a rule which works, you can effectively say that, okay, if this rule happens, tag all the data with this label. So we used model-based active learning along with some rules together to get this high streaming data set. And we found that it can be very beneficial to improve the performance on various classification data sets. So here are all the 6 sentiment classification data set. And you see that so I'm computing the performance on the test data, which the model has not seen till now. But what you see is for some of the data sets, the test data performance can easily be reached by just almost half the data set. So you don't even need the full data set to reach the test data performance. Same goes for say GOP data sets, almost slightly more than half. Clarion is a very huge data set, so it is we still don't reach very high accuracy here. And SemiVal also we can reach pretty good accuracy in just say by annotating around 10,000 tweets. And remember, these are classification data sets, so they have much more than 10,000 tweets. But the more interesting thing is in these situations is oftentimes, as I was giving the example of a fixed corpus. So if I have a COVID corpus of 1 million documents, and I only want to do my analysis on that so that I can convert it into a database format. So all I care about is how quickly I am getting a high accuracy on the remaining data. And for that, what we found is that, like, this is how, like, the accuracy on the remaining data, this is how the model's accuracy increases. And this is where the different selection criteria are important. So, like, this criteria based on choosing the most, what I would say, most unpredictable item, which we define based on the highest entropy of the probabilities, is the best one in terms of quickly annotating the whole corpora. All the other, if you just use a random criteria, then, like, that does not reach as high values as quickly, even on the, like, say, the same sample. So we are looking at the same unlabeled data set, and we just trying to see that whatever remaining unlabeled data we have, how quickly we are improving the accuracy on that. And we see that the entropy based approach, like, really gets, like, very quickly high performance. So next, I talk about a little bit going. So all these, this is something which I've forgot to mention, is like all the analysis which I've presented before this and all the other work which we have talked about have been mostly related to English social media dataset. So now, like, again, we reach this regime of, like, social media, because of its very nature, is multilingual. So people from all over the world participate in, like, social media discussions, and they often, like, make those discussions in their own languages. So here, how we can actually expand our information extraction models from, say, one language to multiple language. And this is where we used, again, the idea of multitask learning, and use it for multilingual learning. So effectively now, instead of training for one task, we train, like, for, like, one task, but for all the languages. So it's similar setting. And here we actually have, like, a two task model. So they were like, the task was identifying various aspects of cyberbullying. So, like, whether it was aggressive or non-aggressive, and whether it was, like, a general or non-general type of, gendered or non-gendered type of aggression. And we can again consider these as two different tasks. So we can combine them as multitask, and then we can also combine all the languages as a multilingual model. And this model performs, like, very well. Again, the benefit of multitask multilingual model often is not just in getting the highest accuracy, but in getting a reduced computational overhead. So if you have, like, you don't have to maintain, like, 5 different models. So here, like, we have a total of 1 plus 2. So two different tasks, and you have, like, 3 languages. So you are going to have, like, normally 6 different models you need to train. But what you can do is, like, just train a single model and get, like, pretty good performance on all the languages, and on all the tasks. Similarly, we expanded it to a large taxonomy of tasks. So, like, you can try out different ways of mixing and matching tasks, and we see that, like, this usually, like, leads to much better performance improvement on all the hate speech identification data sets. Okay, so I think now we are at the stage of doing a hands-on session. So before I go into that, if you have any questions, we can take that, and then we can go for a break for, say, 10 minutes.
There is no question in the chat. Should we go for a break for like 10? My time.
I think, like, let's take a break for 10 minutes, and
Yeah,
I'll just
10 minutes.
set a timer. Hi, everyone. So yeah, there's a question in the chat about how we can use some of the other features. So I think like one of the examples which I we gave earlier was around creating text-based networks from the follow, like how people follow each other, and you can create, or how people are mentioned with each other. You can create a network based on them. Another work which I can talk about, which is directly related to the number of followers, or like direct follow additional data, is related to improving sentiment classification. Is oftentimes like we are like when we do sentiment classification, we are mostly concerned around the text data, but these are all the additional features which are already present in a post which we miss, right? So we just ignore them. So can we utilize all of these features, and like does it lead to some sort of an improvement? So for this work, what we considered was that we wanted to quantify the authority level of a user based on number of status, what their social interest was based on number of friends, followers, how long they have been on the platform, how authentic is their profile, if it's verified, does it have a URL. And then we also wanted to quantify, like, say, various aspects of the tweet, which was like, how topically varied it is based on number of hashtags, number of URLs, reference to a network, like number of mentions, whether it's a reply or a quote. And if we include these features, like first we found that like some of these features have a very distinct correlation with sentiment attributes. So we found that like, say, for example, like negative sentiment is less likely, negative sentiment is less likely from people who have like lesser number of friends. So this can act as a prior. So maybe like, people, so followers and friends are slightly different. Friends means like how many people you follow. And followers is like, how many people follow you. So often like, people who have very like, high number of followers, they usually tend to have like a lesser likelihood of like saying negative things. And like, say, people who have like, say, fewer number of friends, that means like they are followed, like they go and follow like very few people. They also like tend to like have a very less number of negative tweets. So we use these correlation as a feature. Again, like, you should not consider this as a distinct signal. It's just like as a prior signal. Not say like, if I have like few followers does not necessarily mean that I will always be negative. It's just that like, these users were more likely to be negative, and you can use that as some prior information to fix your model. And same goes for verified and non-verified users. And what we found is that if you include these features as part of the model, like almost always like the model's performance improved by almost 2% F1 score. So this is like one work where we have used the whole process, like the whole additional metadata around the tweet. Other, like, there have been a lot of other research work where they directly use the whole social graph to infer better, say, named entity. Like, so one very important task is entity disambiguation, where you want to know that whether like, and the linking spatiotemporal tweets. And yeah, so this paper basically like motivates that if you want to disambiguate an entity, you need to like, utilize some user context. So for example, like if people are mentioning Spurs in US, in UK, it may mean like this Tottenham Hotspur football club, whereas in US it may mean like San Antonio Spurs. So a lot of time people utilize these additional features from the user graph to get like better prediction accuracy for their models. And yes, it's like quite important feature a lot of times, but oftentimes people ignore them because these are harder to gather data sets. Gather features.
Would you please be able to share the link of this paper that you were showing in the
sure.
chat? Thank you.
Oh, sorry. This one, and what was the other one? Yeah, this one. These are the two papers. And apart from that, like I think the other paper which we talked about are mentioned in the slide, like for the networks, the signed and unsigned networks. So one is by Shadi. Shadi is like their public version of that paper also, or not yet there?
Which paper?
The one where you use the signed Enron network.
Yeah, actually, we have two different papers on that. One is about like how we extended this structure balance theory, and the one that you talked about, and I will share both links here.
Okay. Great. So now let's get to some hands-on session. So all of you can see my notebook, right? Okay. So in this session, mostly like this notebook is already done, kind of like I'll mostly be walking through this notebook, but through this, I want to like highlight how you can actually use some of these tools for your analysis. And like, I will go back to this key idea that converting your text data into say some database format and then working with that. So if anyone is not able to like access this notebook, like please let me know. The link to the notebook I will just share again in the chat. Adi, do you also have like access to the notebook, right?
Yes, I do,
Yeah.
and I have shared the
Okay.
the link also. I will monitor the chat. Don't worry if any
Okay.
question comes up.
Great.
I'll
Thank
let
you.
you know.
Yeah. So I will mostly like the setup instructions are already here. So mostly it requires on like a few different. So the main library I'm going to talk about is the social media IE library. And in the past version of the tutorial, we mostly discussed the social media IE library. But I would also want to highlight some of the lexicon-based approaches, like which Shadi has worked a lot on, and like the lexicons which are already available for social media dataset, and how you can easily use them for your analysis. So again, like if you are using the Colab notebook, you don't have to worry about the dependencies. All of these things are already listed. Wait. All of these things are already listed as part of the tool, which is the social media IE tool. So this is the tool which we are using, and most of the features are built here. Some of the features are only in the notebooks, and I would post the notebook, like the final notebook after the tutorial, but the link is already there. So this link is always going to be available. So yeah. And if you want to just install this locally, there are, like, as I mentioned earlier, there are some instructions on the tutorial page. So if you go to the tutorial page, you can go to the setup instructions, and then it has instructions on how to run this thing locally. So again, if you want to do it again, like if you want to use it for your regular analysis, you can do your local install. if you have access to Colab, I would say like use Colab even for your regular analysis because it's like free and it has pretty good resources. So yeah. Some other libraries which we are going to be using is the Twark and Flash Text. I don't think I'll get time to talk about Twark, but Flash Text I will show as well. And yeah, that's all I'm going to talk about in terms of dependencies. So there are like various things which we need to set up. You don't have to worry about them. You don't have to worry about these. So we don't have to worry about the setup instructions. That has already been taken care of. What you need to go on the running model. So first, I will start with the lexicon-based work, which Shadi mentioned. And here we are going to use this library called FlashText. It's basically a library for if you have a lexicon with some categories, it allows you to quickly tag, like say, words from that lexicon with their categories in your data set and identify like, which words from your lexicon are actually part of your text. So I'll be talking about two different lexicons. One is the One is the morality lexicon, which Shadi and Yana have built, and I will share the link of that. I think the link is listed here later in the source. Oh, sorry. Yeah. So when you go to the setup instructions, like all these things are also downloaded. So install dependencies. If you go here, yeah, download models. The download model actually goes and downloads the lexicons as well. So it downloads the social media IE model, it downloads the NRC lexicon, and I'm just going to show like what the lexicon looks like. So it's basically, this is a page. You can just go and download it from here directly. This is like what the format of the lexicon. So it has various words, part of speech tags for each word, which are used for label. Again, like I'm not an expert on this lexicon, so maybe like Shadi, can you like mention like what the columns mean?
I don't have access to the lexicon.
Oh, can you see my screen?
Very, very small.
Let me make it bigger.
Okay. Oh, this is our morality lexicon.
Oh, yeah. No,
Okay.
not the other one. Yeah, the morality lexicon.
Yeah, I saw this NRC. Okay, so yeah, as I mentioned, we extended the morality lexicon, as I mentioned in the previous section. So we have the tokens that represent the actually the words in our lexicon, and then we have the part of a speech. POS is the part of a speech, which can be noun, verb, adjective, or adverb. And one thing that it is important to note that the verbs in our lexicon are all lemmatized. So that is one thing. And then we have the synseth label, which comes from if the word that are in that is in the lexicon is the original word. Is it the synonym of the word? Is it hypernym or is it antonym? So SH, O, and A are representing these labels. And then we say if it is lemmatized or not, and most of the verbs in our lexicon are lemmatized. And then we have the morality description, which is the morality category, actually, which is fine grain, if it is care or harm. And as the original lexicon has it, we have care, which is virtue, and harm, which is vice. So we name it as care, virtue, care, vice, or authority, virtue, authority, vice, fairness, virtue, fairness, vice. And also we gave a number to each of these categories as so it's morality type. It can be numbers from 1 to 12, I think. I don't know if it is, yeah.
Okay, got it. Yeah. So yeah, I will show you how basically like a very simple application of this lexicon And yeah, Shadi, thanks for providing like a detailed version of what this lexicon means. And like, yeah, I did not use all that information, which Shadi has provided in the demo example. Mostly it's a very simplistic lexicon. But for us, like for our use case, I've provided like a simple way of loading this lexicon, as well as the NRC emotion lexicon, which does a similar thing. For each word, it assigns an emotion category. And then you can load the lexicon using this simple class, which I have created, a lexicon class. And so here you can just use this to load the morality lexicon, and it will load it as basically like as a table. And then what you can do is, I want to see like what are the different types of, say, morality descriptions available. So as Shadi was mentioning, authority wise, authority virtue, care wise, care virtue, and these are all the words related to each category. So one thing which like very simple thing which you can do if you are like interested in only knowing that, okay, which morality words are present in a text, and like, what categories these words come from, you can simply create a tagger from these lexicon, which uses the fast text library. And you can tag all the whole text. So like here is a text, and it's just like just a random gibberish text. Like this is a lot of affection, hate for people with love, sorrow, agitation, and abhorrent behavior. I basically specifically chose words which occur in that lexicon. So, and what you can do is like when you do like morality lexicon keyword processor extract keywords, you will get all the keywords and where they occur in the text. So care virtue occurs at the characters 18 to 27. Care virtue again occurs at 53, 57, and so on. So if you just want to use it for, say, like populating your database, then this is the information what you need. If you are mostly interested in, like, say, exploring it visually, then like there is a display function which you can use to see like, okay, there is a lot of affection. This is related to care virtue, love, another care virtue, agitation, authority wise, and abhorrent purity wise. So it's a very simple way of using any lexicon. Again, I did not use the specific features of Shadi's lexicon, which is like using it with part of speech tags, which you can also use it like by assigning a part of speech tag to each text, and then getting the labels, like the correct labels for each word, if multiple labels exist for each word. So just to give an example here, let's say morality lexicon. Sorry. Morality lexicon dot lexicon. And let's say, yeah, okay. So let's say words which have multiple virtues, or words which have, say, words which have multiple senses. So let's say I will do group by token, and then I will just want to see like what different part of speech tags available for this token. So I will just simply do part of speech dot ag and list. It will give me that, okay, most of the words have like a single part of speech tag. So it's easy to tag them. Some words actually are going to have multiple part of speech tags. So like you need to actually ensure that we handle them properly. So yeah, and yeah, basically you can just sort this list by whatever way you want.
Shu, there's a question in the chat. I think it's about the fast text. Is it taking one word at a time or multiple words?
So the fast text library actually it doesn't work on words. It finds the longest span. So if you have like, let's say, affection, if there is a phrase which is affectionate, affection holder or something like that, then it will look at the longest span. So it works on characters, and as soon as it finds a contiguous span which exists in the dictionary, then it marks it. So it's pretty efficient. Yeah.
I think Sadia, if I pronounce your name, sorry about that. I think they raised the hand, so I don't know if you can bring them up.
Okay.
I
Yeah.
don't have that.
Let me try.
This is our
How do
first one.
I?
Yeah, I
Oh,
think you did
presence,
that.
presence,
Yeah.
presence. Yeah. Approve.
I think she's now among the presenters. Or he, sorry about that.
Oh, yeah. So, Sadi, you had a question?
Oh, hi. Yes. So my question was about it if it is taking multiple words at a time or one word.
Yeah, so it basically finds the longest span. So let's say there's like these word tokens, like church father. This is the 2 token word. So it will just find like whether this whole phrase exists or not.
So it's taking phrase by phrase.
So it basically works character by character, and as soon as it finds a long phrase which matches a token in the dictionary, then it stops and assigns the label.
Okay. So these
Yeah.
tokens are coming from this morality lexicon, right?
Yes. Yeah,
So
and we go ahead.
So it's predefined.
It's predefined. Yeah, in this case, yeah, like I'm just using the lexicon and then like using the lexicon to tag this sentence.
Okay. Thank you.
Okay. Yeah. Thank you. So yeah, this is one example. Okay. Where did it go? So next we go to an Emolex lexicon. Again, like this lexicon is for emotion identification, and it's a very like popular lexicon for doing like simple emotion and sentiment analysis. You can read more about it here. I've provided the link in the notebook. So yeah, it has like around 14,000 words, single words. And again, it also uses sense information, but again, like I am not using all the sense information. So let me just show it to you how that lexicon looks like. So I will load the Emolex lexicon. And oh yeah, there's 2 versions of Emolex, one with senses, one without senses. So I'm only using the one without senses. And it has a word, what is the effect and what is the association. In reality, it has a 0 or 1 association, but I'm only concerned with tagging words which have a positive association. So I drop everything which has like a no association with an effect. And then we use the same way, like we use a tagger based on this lexicon, and we create a tagger based on this lexicon, and then like again we get like the text annotations. This is what you will use if you want to put it in database. And then we get a visual representation also if you want. So like affection is related to trust, hate is related to sadness, love is related to positive, sorrow for sadness, and so on. So, and there are cases like, so some of these might actually belong to multiple affections, but I'm only like picking one of them. So like in no particular order. So this is just like a very simplistic representation of tagging by the lexicon. Any questions? So these are like all the 2 types of lexicon I'm going to cover. And like once you have this information, you can use it to do your analysis. So effectively, like most of the time, you just care about for a given tweet, you want to get this information that this tweet has words related to trust, so words related to negative. Sometimes people just count how many negative words are there, how many positive words are there, and so on. Any questions on this part?
So Sadia asked, do you have any lexicon defined particularly for hate speech?
Yes, there are. I mean, I'm not showing it here, but yes, there are a lot of lexicons for hate speech. So speech lexicon, and there's actually one for multilingual hate speech. Yeah, Heartlex. Yeah. So this is the hate speech lexicon, Heartlex lexicon. So it's a multilingual hate speech lexicon. It is available for like all these different languages. Let me show you an example from English. So let's take a look at English one. And I don't maintain this. It's another group, and it's on the same format. Like, so part of speech category stereotype is so I think like the stereotype and lemma, and speech category. Oh, stereo. Okay, so yeah, so the lemma is this one. Snotty, meant, can't. Again, I don't know many of these words, but yeah, some of the words like actually are related to, yeah, like they are like abusive words effectively. And yeah, if you speak like a different language, you can find like probably lexicon. Again, like it's best to check whether this lexicon is the right lexicon for your use case. But yeah, this is what is available, and there are like some other lexicons also. Oh, you already posted. Yeah, thanks. Okay, so now any other questions on the lexicon based things?
There is no question now.
Okay, yeah, so let's move forward. Yeah. So just to close the lexicon section, like lexicons are actually like often very powerful. If you are just starting on a new problem, I would always suggest like, starting with lexicon and probably using some of these lexicon expansion based approaches which Shadi mentioned. Like they can really get you like from a very good accuracy without having any sort of a training data. So it's basically like when you build a lexicon, you're building some different rules. And you can use these lexicons to even prepare your training data. That's what we did in the active learning setting also. But yeah, like I would always suggest like, start with some lexicon based approach to get an understanding of your data set. And then like, move to like some more like machine learning specific areas. Like model-based approaches, because like machine learning models have different types of errors. Lexicons have different type of errors. So if you want like high precision, then like probably like a lot of times like lexicon-based approaches can give you like pretty good precision if you know exactly what the rule is. So now let's go to the aspect of multitask tagging. So I have like in the toolkit, we have like two different types of model, one for tagging, one for classification. So each model, like the tagging model does like tagging for 10 different items. And the way to use it is effectively like, you just import a tokenizer, and then you just import like a few predictor. And like we are still like working on the API to improve this, but it's pretty simple. You load the model, which is already there. And then what you do is, yeah, you don't have to worry about this. I've just printed out some labels. These functions are also already implemented in the library now. But what you can do is simply just use the model, just do like a predict JSON. It has by default, it has a text built in. Like this is the default text. Barack Obama went to Paris and never returned to US, and some other text. And you can use it to get the output. So here is the output of the model. And I'm going to show you what this output looks like. So effectively, so this is what the output looks like. Barack Obama went to Paris, never returned to the US. Like basically just a random text which I've typed. Barack Obama refers.
Sorry, Shiv, can you please like zoom in a little? I think like the text is not readable. Thank you.
So this is the text, and like you see, like each token has been labeled with different types of part of speech labels. Each token has again been labeled with different types of named entity labels. So the reason these are different types I call because they are based on different training data sets. And you see like most of the labels agree. So like almost all of them correctly identify Barack Obama as person, this thing as a noun phrase, it's a noun person type, and so on. Same goes for location. Some like annotation guideline, you see like they tag the USA as the right location. Some other like call it like say just like the USA part as the location. Same goes for Paris and so on. So this is one way where you can get like the model output. I will show you some other examples. So the way you are going to use it is like, let's say you have, again, like as I was mentioning, you need a tabular format for this. So when you run the predict df function of this model, it gives like, say, this tabular sort of input. And let's say, let me take a more realistic example. Where is it? Okay, yeah, sorry. So yeah, in this case, I've already set the text here. If you pass text to your model, it will do it for each text, and each text will be identified with its own ID. But if you just call it normally, like, it has some default text built in. So we will just use that text to get the output. So you'll get the output for all the sentences, and you can use that output to say populate your database and then like say search some queries, like to perform some queries. Oftentimes these labels, however, are not the labels which you're looking for. So for example, for Shadi's use case, if you are interested in part of speech tags, then yes, you get all the tokens and you get all the part of speech tags. And now if for people who come from SQL background, you can simply do a SQL query join based on tokens and the lexicon and the part of speech tag. So like tokens, part of speech tag, and the lexicon, you'll just do a query join and you'll get the output. For entities, things are slightly different. You often don't want these B per I per labels. You just want the whole chunk of entity. So we have some helper function for that also in the library, and that allows you to extract, say, for this sentence, these two words refer to the entity called person. These two words refer to a location entity. This word refers to a location entity. So here I'm taking an example of a raw text. I think this one was taken from some time back. Like I just copied an random tweet, and you see like the whole tweet has been tagged. And this is how you like pass your own text to your model. So you can keep running these cells also on your own side, and you get like all these various entities. So you see like you'll see different models identify different entities. Almost all of them like have Ryan Gosling, Chris Evans, Russo brothers, the Gray Man, and so on. Same goes for all these other models. You get like all these outputs, and then you can use these output to just populate your database. So the way you're going to have your database filled is like your document ID, start index, end index, and the phrase. So this is what you'll become like your entity database.
Shub, one question that may come up is that, so like you mentioned that you have different models here. How should people choose the best one? Like if they want to choose just one of them, how can they choose the best model for the purpose of their study?
Yeah, so actually there are two approaches there, and that's a good question. We have the reason I like show all the outputs is not to confuse, but like to give as much information based on the way the model was trained. One way is because many of these labels have similar sounding names. So based on your use case, so let's say you know that most of the time in your sampling, you find that the person labels are pretty correct and well aligned. You can simply find a mapping and just do average voting across all these labels. And you can use that as your output to say like, okay, all the models predict this phrase as a person, so I will use it as a person. And only populate your database with the most, say, high agreement labels, high agreement entities, or like say high agreement part of speech tags. So that is one way. Often you can find like these mappings like very easily. Like say for part of speech tags, as I showed you in the label diagram, like how the labels are related to each other. So you can use that label diagram to find a mapping that, okay, these labels are related. So let's make sure that like, we do an average voting across these labels only. Yeah. In
Great,
future version, oh, go ahead, Shadi.
No, I just wanted to thank you.
Yeah. So yeah, in future version, like I would probably integrate the label aggregation based approach in as part of the tool. But yeah, like that's something not yet implemented there. So this goes for entity linking, sequence tagging, and you see like, all these models work. You can run it on like a larger amount of text. So often you'll have like a big data sets, and you want to annotate all the data sets with this. So the way I would suggest is like, process the model with small chunks of data sets, and then like, get the output, and just populate your database with the output. Another thing is like any output, if you use this function called predict JSON instead of the predict DF. So when you do use the function predict DF, it outputs a data frame, which is easy to port or like move or save as a database. But oftentimes, if you just want to explore, then you can do a predict JSON format, and it outputs actually a JSON, which you can then copy. And I have already linked like where you need to use this. So where did it go? Like, so there's a visualization tool where you can just copy paste this. So this is the visualization tool. It's part of the notebook. And when you go to this visualization tool, you can just like put this, and it's going to show you like, how the labels are aligned. So this is like, if you're just trying to explore one-off examples, this is like a good visualization tool. So if you know that, okay, like what kind of errors is your model making, you can use this visualization tool to effectively like explore how the model is performing. Now we move to the classification aspect. Again, it's the same format. You load a bunch of files. So let me view collapse sections. Okay. Visualizing outputs. Oh, okay. So running models. Okay, yeah, so now we go to the multitask classification setting. So here also, like, the API is very similar. You have two functions like out. I will show you like predict JSON and predict DF. This one does not have a predict DF because for classification, like I found it to be like slightly difficult to implement. But basically, you get a JSON, which you can later like easily convert into a data frame. And so for a given text, again, you get like all types of sentiment scores from every model, like every data set. So you have like sentiment from like Clarion sentiment based, like which has negative, positive scores. Then uncertainty values, like all the probability scores and so on. And then once you have this, you can actually use this again to to basically like, visualize this. So effectively, like, you can just copy paste this and go back. And just visualize this. So sorry, I have to refresh the page. Yeah, you can visualize this, and yeah, you will see like, all the scores in one place. So again, like this place is more for exploration. If you're mostly just interested in like, putting things in like saved format, like you can just directly use the tool. So here are like some other examples of how like the tool performs. And in the end, like, I've basically embedded the visualization tool as part of the notebook. So you can directly use this tool directly in the notebook. So just instead of going to a different page, you can just copy paste everything here. And if you join the two outputs, you can actually, like, this one has both classification as well as tagging. So you can basically like display both types of labels in the same page. So this is like even more fine-grained annotation, exploration. So yeah, this is the tool which we have. It's freely available. And yeah, if you want to include any other features on it, feel free to basically like create any issues here, like, so that like, we can improve it. But yeah, like, you're free to use this tool. It also has some active learning component, which I could not demo, but like the tool already has libraries inbuilt for implementing active learning. Yeah. Any other questions on this part? Okay, so I will now move back to the last section, which is,
Sorry, Shub, can you just one more time copy the GitHub link of your repo that you just showed in the chat for people who may have missed it? Thank you.
yeah, thank you. Why can't I post it?
I can also do that if you cannot.
Yeah, no, I just posted that. Yeah.
Oh, perfect. Thank
you. Okay, so back to, okay. So now I would like to, we are almost at the end, but I would like to like demo the last hands-on tool, which is the visualization tool, which I talked about in the beginning. It's for visualizing the whole the whole corpus with the networks between people, and how like the various data sets are connected, like how the various posts are connected to each other. And let me just, so you can see my screen, still see my screen, right?
Yes.
Okay, yeah. So this is the social communication temporal graph, which we have built. It's basically a tool to take like a large like a big data set of digital social trace data and then like visualize it. So the first example I want to show is like basically tweets, which are, so let's say like, you have a corpus of tweets and you want to identify like, which users tell the most positive things, which user tell the most negative things. So these all tweets are related to a campaign, and then like you can identify that the positive tweets are coming from certain users. This is another user who has like posted most of the positive tweets. But not just that, you also see like how the tweets are distributed across time. So you see like certain users, like the positives and tweeting user, like they have posted a lot of like popular tweets across time, where like some other users like who have posted like only one positive tweet over time. Now this is like the initial like version of this tool. Since then, like it has been applied to like various other use cases. So for example, this is the example which I showed you earlier on visualizing a Facebook group. So here, this group is for a course project. So you can see like, how various posts in the group were created, and like, how, like when do people comment on those posts. So actually like one interesting thing which came, hello?
Yeah, there's a comment. Please zoom in. I
Oh,
wanted
sorry.
to say yeah, thank you.
Sorry. Yeah. So yeah, this is like a class Facebook group, and then like these are posts which are like when people are posting on the class discussion, and then there are comments. So a lot of times like the most popular comment is like by the TA. And like oftentimes you see like the highest activity in comment was happening around when the assignments were due. So the main assignment due dates were actually provided in the visualization to say like that's where like around the assignment due dates, like that's where like a lot of high comment activity was happening. And then like people are posting like links, people are posting like general text style posts. So you can explore your data set using these type of visualization. Another version of this visualization is, so let me just share this link for everyone to. Yeah, so another version like of it I have utilized is like to find like say recent tweet sentiment. So this data set is about say about 2 politicians, and I would like to compare like who tweets positive and who tweets negative, and who tweets positive or negative about both the politicians. So people who mostly tweet positive about one of the politician wait a second.
Sorry, can you zoom in a little? Like it's a bit hard to read.
Yeah. Oh yeah, sorry.
Yeah.
This one is just based on positive, negative. So these are all the tweets people have created, and then these are the sentiments aggregated at user level for various users. So this is like a improved version of the first visualization which I showed you. You can use it to compare tweets people make about 2 different entities. So here I have 2 different entities, Narendra Modi and Rahul Gandhi. And there are people who tweet about both of them. So for example, like this person has tweeted about both the people. This person has tweeted about both the entities across time. And mostly like, the person has tweeted about like say Narendra Modi and less about Rahul Gandhi. And you can use it to find like, say like a lot of high retweet people are tweeting about say Narendra Modi, and like the medium retweet people are tweeting about say both the entities, and like very few like high retweet individuals are tweeting about say Rahul Gandhi. So this is like, and both of these are like Indian politicians. So it's like you can use it to explore like how different people talk about various entities. I've also like applied it to study Wikipedia revisions. So Wikipedia revisions are also an example of like digital social trace data, where users edit Wikipedia pages, and then like so these everything at the bottom are edits, everything at the top are users, and then we see like which users have visited the most page about different entities. So we see like this user has mostly edited like pages about Narendra Modi. This user has edited pages about both the entities. So what you can use it to find like which users are more like say more political, like I would say like political authors, and some of the users are more like say specific entity specific authors, and you can use it to identify these users very quickly. So that's the visualization, and you can apply it to any different data sets. Go ahead.
Shub, I think like you can also mention that they can use their access token, and like they can use their own information to create this this data. I think you did not show that.
Yeah, sorry. Yeah, I can show that. So first of all, for Wikipedia, you don't need any access tokens. So if I just update this with say Donald Trump, and this one with say Joe Biden, I can easily get all the data set. So Donald Trump is in red, Joe Biden is in green, and blue is for both of them. So we see like these are different users who edit pages of both Donald Trump and Joe Biden. For tweet-specific cases, you can actually fetch the tweets directly from using your own API key. So I'm not going to show my API keys, but if you scroll down to the page,
I think you can open that in an incognito, maybe.
Is my screen still visible?
Yes.
Okay. Yeah.
Yeah. Perfect.
So this is where you can like basically put consumer key, consumer secret. So this is what you get when you sign up for a Twitter API, and you put your 2 search queries. And when you do save, it will basically create code, and then you do like a run code thing. So when you do save, it will create some code, and then you have to press run code. And once the run code finishes, you have to press like parse data and plot. So once you do these 3 things, it will automatically create everything, and it will like make the visualization for you. So I've already built it for a set of tweets.
There is one question here. Is this data real time?
Yes, if you run it, it's real time. So if I say, let's say Donald Trump and Joe Biden, the data I am showing right now, that is old stored data for the visualization, but I can create like the, let me just, what I say, like pause my screen for a second, and then I will run it. Save and generate code, and then run, and it will run. So effectively, like if you have your keys from social media, like so from the Twitter API, you can run it. Pretty straightforward, and it takes some time to launch, but when it finishes, like it will show you like you can click parse and plot. And once it finishes, it basically stores the data on your browser. So later when you visit this page, your last used data is saved. So that's how I'm able to show this data to you, because I ran this once, and that data was showed to me, saved on my side. So next time when I visit the page, I'm reusing the same data. But if I like relaunch the query, then it'll take some time, and regenerate that data set.
There is a question that it says, does it take tweet IDs? Is there a way to save the tweet IDs that you visualize?
There might be a way. Basically what it does is like it's creating a Python script, and it is generating. So there might be a way to store them. I don't have it handy right now, but like it's very easy to, because what it creates is it creates a public Jupyter notebook. So if you visit that Jupyter notebook, that's where it will create something called a tweet.json. And that's where like that tweet.json is where your data will be saved. So you can just go and download it. So yeah, it's taking some time, but yeah, if it finishes, I will let you know. So I think that's all we have. Anything like from Shadi and Yana from your side?
No, let's see if there is any question. If anyone wants to raise their hand and ask question, please feel free to do that.
Yeah. And I'll put the last slides there. So these are like some of the tools we already talked about. The notebook links. I will be putting all the slides in the tutorial page. Past tutorial slides are also on their respective pages. Yeah. Okay.
I think there is a question.
Yeah.
Instead of query, can we give tweet IDs to retrieve the JSON data or for tweets?
Not directly in the interface. You may have this again. This code, the library code, is also open source. So effectively, like you can reuse that code to work with tweet IDs. But the existing version, like I have no way of like adding tweet IDs right now.
Yeah.
Yeah.
But you can
Yeah,
easily use that on your repository.
Yeah, it's pretty easy to include that. And basically, as soon as you have that JSON data, like you can like use that JSON data to get the required visualization. So let me see if this has finished. Okay, so yeah, this has finished. So I think parse and plot. Okay, so now I have the final visualization, I think, just in time. So the query was Donald Trump and Joe Biden. So if you see, like I got a tweet, all the tweets are from, say, today. So these are like, say, Wednesday, April 14th. All the tweets are from recent timestamp. And you have like, these are people who are tweeting about both. These are people who are tweeting, like this person is mostly tweeting about Joe Biden and mostly tweeting about Trump and so on. So yeah, this is like a way you can visualize this type of data set.
Can I ask a question? I think like the Twitter API was like, you can just get the 7 recent days data. Is it the same, or like, do we have access to historic data as well?
I think it remains the same. Have to check, but like, yeah, the general, so I'm mostly just querying like some recent tweets, just like 500 recent tweets.
Okay.
So, yeah.
Cool.
And just to quickly show, like, this is what the data comes out like. So this is like what the data looks like. So it's effectively a tweet JSON. And once you have this JSON, you just parse it. So let's say, like, take the example of this tweet JSON. It has these fields. Oh, so this tweet JSON, we have one for each query. So, and then we just like, compute some intersection and union, and then just plot everything together.
So they have access to the tweet IDs as well. In the JSON, they can just easily save that and reuse it later.
Yeah. Exactly, yeah. So effectively what you can do is like, you can just copy paste this whole thing, and yeah, like just let's say maybe a text editor or online. So if I just have like, say, online text edit. Oh, sorry, let me just show it to you. JSON lint, this one, like you can just copy it here, and yeah, it's basically like, this is the format. So you have Donald Trump as one query. So all the tweets for Donald Trump are under this. And same goes for Joe Biden. So there's going to be another entry for Joe Biden, and yeah.
Yeah, very useful. Thank you.
Yeah. And it has ID and everything else. That's it. I think we are also at time. So if there's no other question, then yeah, thanks for joining. And yeah, hope you enjoyed this tutorial.
Thank you, everyone, for joining us. Please reach out if you have any question. Our email addresses and Twitter IDs are on the slides. If you need anything, need more information about any of the studies that we mentioned, just please feel free to contact us.
Yeah, thank you.
Thanks, everyone.
Thank you.
Have a conference. Bye.
Shadi, can you stay for a second?
Yes, sure. I think we can. Oh, there is a
We can
hand
pause the
raised.
recording, right? Yeah,
I don't know if Sadia has. Okay. There is. I think Sadia has a question. Shu.
Yeah.
Hi. So I have a question. First of all, I'm very beginner in these things, so I'm doing one project which requires some data extraction from Twitter. Can I ask a question about that?
Mm-hmm.
Yeah.
So I am trying to use the Tweepy to extract the data. So what I have is one list of tweet IDs. I am trying to extract the tweets regarding those tweet IDs. So the problem is when I have completed the extraction and the JSON data in JSON data format. So when I'm trying to use that JSON file, there are some issues with the file. So I can't really use that file. It has some bugs or something. So is this type of error pretty common?
I mean, yeah, sometimes like when you save data, like some of these errors can happen. Like again, like we can't, I can't like say anything without knowing what the exact bug is, and probably like it's like too much scope. But in general, like what I use is you can simply use like, so the way TweetyPie returns it, like it will return one JSON for each tweet. So what you can do is like there's a format called JSON lines, and you can try storing it in that format so that it's easy to save and read the file line by line, which like if there is an error on one tweet, it will not affect all the other tweets. So that's one way like I have like figured a way to fix it. But yeah, like you can look at like how people have stored tweets and like some of the codes.
Right. Thank you.
Thank you. Okay, I think if there's no other questions, so I think yeah, let's close this.
Yeah. Thank you, everyone.
Thank you, and I'll stop the webcast also.
Yes. Yeah. Okay.